All right, now to see if I can answer my own questions. So, to all the methods people out there, hopefully you've had a go at the methods exam, multiple choice questions that I put together in preparation for your exam, November 6th, I think. So, getting close. Anyway, if you want to look at the questions I'm about to go through, have a look at this document here, and these will be the solutions to that. So, question one. This was question one. Given that f of x equals 2x plus 1 and g of x equals x squared minus 3, what is the value of f of g of 2? Okay, basically evaluate g of 2, sub 2 into here, gives you 1. Take the 1, sub it into f. 2 times 1 plus 1 gives you 3. And just for visual effects here, we've got the graphs. So we've got f of x is the red one, g of x is the green one, and f of g of x is the blue one. You can see that when x is 2, y is 3. So when that x value was substituted into g, gives you 1, and then you sub the 1 into f of x gives you 3, and you get something like that. So the answer is B. All right, next one. Consider the polynomial in general form. F of x equals a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus so on and so on. What is the maximum number of turning points the graph of the polynomial can have? Well, if we just step this out here, you can see that we've got x to the power of 1 here. And so, a quadratic, which is x squared, has maximum of 1 turning point. Cubic has a maximum of 2 turning points. Quartic has a maximum of 3 turning points. And so hopefully you realize that it's 1 less than the highest power. The highest power in this case is n. So the answer is B, n minus 1. All right, for the graph of f of x equals 2 sine x minus b, the values of b that ensure f of x is greater than 0 for all x are. Okay, probably use a slider on your calculator for this one. Graph the function. You need this to be greater than 0, so you need this to be moving up. So you'll notice when b is strictly less than -2, this function is always positive. So it's a bit tricky there because this is minus b, so it's less than -2. So if it's less than -2, you're substituting in a number that's less than -2 into something here. So that's going to make it positive overall. You need to shift it up more than 2 because 2 is the amplitude, right? Hopefully that makes sense. So the answer there is less than -2. Question 4. The set of ordered pairs, -4, -1, -4, 1, 6, 8, and 6, -3 is 1 to 1, many to 1, 1 to many, many to many. Hopefully you saw that it is 1 to many. One x value, aka -4, goes to many y values, 1 and -1. And similarly, 6 goes to 8 and -3. So one x value goes to many y values. Remember, it's about testing for correspondence. So it is 1 to many. And it's not a function because it fails the vertical line test. So it can't be the first two because they describe functions. Okay, next one. If a is greater than 0 and b is less than 0, the graph below could be represented by which of these rules? Okay, hopefully you realize that our ordinary e to the x graph goes like this. It has this sort of shape. So you can see that this is going in the opposite direction. So it's been reflected in the y-axis, which means in our rule, the x value will be negative. So it can't be b straight off the bat because it's been reflected in the y-axis. Okay, then we need to decide between the other ones. Well, let's put a to be some value. So let's put a to be 1. Okay, so we get e to the -x. So let's put a different value there just so it looks a bit better. So let's do 2e to the -x. Okay, b, does b need to be positive or negative to shift it up? Well, if it's positive, if b is positive, then it gets shifted down because it says b is less than 0. So we actually need b to be negative. So let me explain. So for example, if b was -1, because b is less than 0, so we would get a value substituted in here that's negative, so it's minus -1, which is +1, which would shift the whole thing up 1. So tried to be a bit tricky there with that question. I don't know how successful I was. Next one. Let f of x equal 1 on x minus 2 and g of x equal root x. The domain of f of x multiplied by g of x is. Okay, hopefully you can recall when you've got the product of two functions, the new domain is just equal to the domain of the first one and where it intersects with the domain of the second one. So if we look at this function here, 1 on x minus 2, that's this green line. This is the domain. The only thing you can't have is positive 2. So all real numbers not including 2. G of x is root x. G of x, root x looks like, a tick. And that goes from 0 to infinity. And so the blue line is going to be the domain of f of g of x. It's going to be the intersection of the red and the green lines. So where do they overlap? Well, they overlap from 0 to infinity, but you can't include 2. So sure enough, if we graph these functions, that's f of x doesn't include 2. That's g of x, 0 to infinity. Okay, this is f of x multiplied by g of x, and you can see that it also doesn't include 2, but it stops at 0, doesn't go negative. So it goes from 0 inclusive to 2, not including 2, in union with 2 to infinity. So hopefully that makes sense. I feel like that's hopefully not too bad of a question. This one I tried to be a little bit tricky, see if I could trip people up. A fair coin is flipped 10 times. What is the probability of getting exactly 7 heads? Well, hopefully you're aware of the binomial distribution. This is a binomial experiment. And this is what the binomial distribution says. N choose x multiplied by p to the x by 1 minus p to the n minus x. Okay, x is the number of successes you want. So in our case, we want 7 successes. We want exactly 7 heads. So we want our discrete random variable to equal 7. And we're doing 10 trials. So it's 10 choose 7 multiplied by the probability of success, which is 1/2 to the power of 7, multiplied by 1 minus p, which is also 1/2 in this case, which is the probability of tails, so not a success, raised to the power of how many non-successes you had. So you would have 3 failures. If you got exactly 7 heads, then you must have got 3 tails, right? So I tried to trip people up here a little bit, because if you do the working out, you'll get 10 choose 7, and then you get, hopefully you apply your index laws here, you get 1/2 to the power of 10, but that's none of the options, right? And this is where you need to be aware of your symmetry properties of Pascal's triangle. 10 choose 7 and 10 choose 3 are the same thing. So for example, if we look at Pascal's triangle here, 7 choose 2 would be the same as 7 choose 5, for example. The same would be true of 10 choose 7 and 10 choose 3. So you get that 10 choose 3, 1/2 to the 10 is also the same thing. And that should make sense. It should make sense because getting heads or tails, if it's a 50-50 experiment, is the same thing, right? So getting 3 tails is the same as getting 7 heads. So hopefully that's another way to think about it. The other way to be cautious of is to just put these numbers in your calculator. These are just numbers that you can calculate, as in their decimals. So if you got this answer, put it as a decimal and then check that answer against which one of these works. But yeah, hopefully that was a good question. I liked that one. Okay, let x and y be discrete random variables with probability distribution shown below. For what values of k is the mean of x greater than the mean of y? Okay, the mean of a discrete random variable is the probability multiplied by x, by the value of the discrete random variable, and then you add them all together. So 1/4 times 1 plus 3k on 4 times 2 plus 1 minus k on 4 times 3, and so on. So that gives you this, and pause the video and read it, but put that in your calculator, you get 3k on 4 plus 2. All right. The mean of y is 11 on 4 minus k. So you need this, 3k on 4 plus 2, to be greater than 11 on 4 minus k. Chuck that in your calculator and solve it. You get k greater than 3/7. So the mean, the average of this top distribution is greater than the mean of the bottom distribution as long as k is greater than 3/7. So hopefully that is a straightforward question. It's a bit wordy and it's a bit of computation, but hopefully it's not too bad. Right, these are the kinds of questions I hate, but I made it and we got there in the end. Anyway, for 2 events, the probability of A equals 0.35 and the probability of B equals 0.45, and the probability of A given B equals 0.22. Which of the following statements must be true? Okay, let's break it down. I'm actually going to start at B here. A and B are mutually exclusive events. Mutually exclusive events means the Venn diagrams overlap. So some things that are in A are also in B, or the events can co-occur. So let's think about that for a moment. The probability of A given B hopefully you know the conditional probability rule says that it's the probability of A and B divided by the probability of B. So it'd say that therefore, if we just rearrange this, the probability of A and B is equal to the probability of A given B multiplied by the probability of B. So we've just multiplied the probability of B to the other side. Okay, we've been given A given B, which is 0.22, and the probability of B is 0.45. If we multiply them together, we don't get zero. We get 0.099. So it's not equal to zero. So the intersection doesn't equal zero. So they're not mutually exclusive. So B can't be true because the intersection doesn't equal zero. Okay, let's look at A now. Probability of A and B are independent events. All right. The probability of A and B, we just worked that out to be 0.099. But for independent events, the rule says that the probability of A and B equals the probability of A multiplied by the probability of B. So you take 0.35 and multiply by 0.45, and that equals 0.1575, which is not equal to 0.099. So the events must not be independent. Okay. C, A and B are independent events because the probability of A given the probability of B is not equal to the probability of A. Okay, this would be a proof for why they are not independent. So that's no good. Yeah, I just wanted to make sure I explained that right. Yeah, so if they are independent, this is true. So it says that this isn't true, so they're not independent. So this sentence contradicts itself. I think it's a double negative situation going on. I wrote the question, I still can't work it out. It's tricky. Anyway, the definition of this last option is the definition of the intersection of two events A and B is the probability of A given B multiplied by the probability of B. So hopefully that one seems like the most obvious answer. Okay, let's move away from that one quickly. All right, if f of x is a probability density function, the value of k is okay, probability density function means that the area under the curve must equal 1. So there's certain values of k that will give us an area underneath this curve equal to 1. So this is no good. That's getting bigger, so it needs to be smaller. At some point, it's going to get to 1, and there it is, 0.38 approximately. Now, that is 3/8. Now, do not think that 0.38 and 3/8 just that the three that this number has anything to do with the way the fraction is expressed. But in any case, the answer is 3/8, and that is, as a decimal, that's 0.38. The way you would solve this on your CAS is you would do k multiplied by 1 minus x all squared equals 1 between -1 and +1 and solve for k, and you'll get an answer of 3/8. Yep, that all checks out. So hopefully that makes sense. Okay, next one's going to be a bit tricky, I think. If f of x equals 2x plus 1 over x minus 5 and g of x equals the square root of x minus a, f of g of x has a vertical asymptote at x equals. Okay, here are the graphs. Let's just have a play around. The blue line is f of g of x. You'll notice if a is 0, we get a vertical asymptote at 25. So that means that basically what happens here is the square root of x minus a can't equal 5, right? Because if there's a 5 in the denominator of this function, then we're in trouble. So basically, if we set this equal to 5 and solve it, our answer will be, if we solve it for x, our answer will be 25 plus a. So you get a vertical asymptote at 25 plus a, as you can see. If a is 5, 25 plus a is 30. So you get a vertical asymptote at x equals 30. So hopefully that question also makes some sense. Next one. All right, this question is a head wrecker, I think. If the integral from 0 to 3k of f of x on k dx is equal to what? To which of these? All right, this is where you need to know about integral properties. Okay, and once you recall this integral fact, this question becomes very easy. But if you don't, I think it's reasonably challenging. So if we look here, the integral from 0 to 3k of f of x on k. Okay, So if we were to look at this right-hand side here, I wrote the integral property wrong there. So this is what it actually says. The integral from Ka to Kb of f of x on k dx is equal to k multiplied by the integral from a to b of f of x. I'll put a link below to one of the integral property videos that I've made about this, but basically this represents a dilation from the y-axis by a factor of k. So yeah, it's equal to this whatever k is multiplied by the regular integral without the factor k in it. So I'll put a link below to explain that in more detail. It always stumps me. I don't know why. Anyway, onwards we go. A bag contains three red balls and 5 green balls. 3 balls are chosen at random without replacement. What's the probability that at least one ball is red? Okay, so the probability at least one red is equal to 1 minus the probability that they're all green. Because if you get at least one red, that's the exact opposite of getting all green, right? Thinking of a tree diagram, the only way you can not get a red is to get all green. So 1 minus, but it is without replacement. So you don't put the ball back in. So it's 1 minus, right? 5 out of 8 multiplied by 4 out of 7 multiplied by 3 out of 6, which is 23 on 28. You could also do this with the hypergeometric distribution approach, which I'll put a link below for as well. But I think that way is probably easier in that one. Probably could have made that question a bit harder, but hopefully it's instructive if nothing else. This question, famous question 14 in my mind, this took forever. So parts of the graph of f of x equals sine 2 pi x and g of x equals a half sine 4 pi x are shown below. The pseudocode below describes an algorithm to find the value of x where the functions are furthest apart. So this is our code. Define f of x, define g of x, define h of x as the absolute value of f of x minus g of x. Set the max distance to 0. Set your best x equal to 0 to begin with. Set the step size equal to 0.05. Okay, while or as long as x is less than or equal to 0.5, the current distance is equal to whatever h of x is. If the current distance, if the current distance, h of x, is greater than the maximum distance, then set the maximum distance equal to the current distance. Okay, and then set your best x equal to x. Okay, then increase x by the step size, which is 0.05. Return the best x value and return the maximum distance. The pseudocode will return the following value for best x. Okay. What you need to basically understand to answer this question is that you're going up in step sizes of 0.05 and you're trying to find the x value where these functions are furthest apart. Straight away, you should be able to knock out b. B is not in an increment of 0.05, so it can't be b. And then what I would strongly recommend on your CAS is you'd actually go to a list and spreadsheet. Down the left-hand side, you would put 0, 0.05, 0.1, 0.15 is one column. And then in the second column, you put f of x minus g of x, and then rank, and then evaluate that down that column with those x values from the other list, and then see which one gives you the largest distance between f of x and g of x. And your answer will be 0.35. 0.33 is a distractor in here that I put in because 0.33 gives you it's the closest, it's the correct answer if you just worked it out manually. If you worked it out sort of using calculus or some other method, but it's not in the correct increment step size. So got to be very careful there. Okay, hopefully that makes sense. You just sort of need to understand what the code's trying to do, and then you should be able to work that one out. Okay, if alpha and beta are solutions to the quadratic equation ax squared plus bx plus c equals 0, the value of alpha plus beta and alpha multiplied by beta respectively are. Okay, solutions to the quadratic equation is the quadratic formula. So alpha equals, one of the solutions is the negative component of the quadratic formula, and the other solution is the positive component of the quadratic formula. If you add them together, the discriminant parts, the square root parts go away. You get negative b minus b, which is negative 2b, all over 2a. Cancel the 2's out, you get negative b on a. So it's between b and c, it can't be a or d. And if you multiply them, well, you can use your calculator to multiply that by that, and you'll get C on A as your answer for that. So there's a neat question. Almost there. Let f of x be a function between 0 and A such that f of x equals x log e of a on x. The maximum value of f of x is, I think it's a really neat sort of question here. It sort of looks like this. If we change the value of a. In any case, this is no use to us. This doesn't tell us what the value is. What you need to do here is you need to get your calculator. You need to differentiate this and set it equal to 0. And then solve for, solve it for x. And then take that x value and sub it back into the equation. Actually, it turns out you notice that these values are the same. So these solutions actually lie on the line y equals x, which is pretty cool. But yeah, the answer, which I clearly haven't shown here. One second. Yeah, so the answer's B, A on E is your answer there. Yeah, I feel like that question's actually pretty straightforward, I hope. I feel like I didn't make these questions hard enough. You might disagree, but yeah, again, straightforward. Differentiate it, let it equal 0, find the x value, take that x value, sub it back into f of x, and that should give you A on E. All of that's in terms of A, right? Okay, but yeah, I think it's a nice looking question. This is the nicest question, I think, though. So this is a cool one. Consider the hybrid function h of x equals kx plus 1, where x is greater than or equal to a, and x squared, where x is less than a, but a is an element of real numbers not including 0. The value of k is such that h of x is continuous at x equals a. So it needs to be continuous. So again, continuous means you can draw it without lifting your pen. So basically what we want to do is we want to set them equal to each other. At the x value where we want them to be continuous, we need the functions to equal each other. So k times a plus 1 must equal a squared. And just rearrange for k, and you get a squared minus 1 on a. Pretty cool. I was doing this question, I had to make some adjustments, but yeah, I reckon it looks pretty cool. It's always continuous and it even does some cool, wacky stuff here. I didn't realize until recently that at that point there, it's a equals 0, it's undefined. So is that continuous at that point? So that's why I had to chuck this in. Real numbers not including 0. In any case, get something like this, right? Pretty cool. So yeah, there you go. 3 to go. The graph of f dash of x is shown below. The graph of the first antiderivative, graph of y equals f of x, the first antiderivative of f dash of x could be, right, the answer here is A. Basically, you need to look at these options and think, all right, this is the derivative of one of these. Which one is it? Well, it can't be C because there's sort of this undefined part in C, or at least part of the graph we can't see. It can't be B because B has 2 turning points. And that would mean on the derivative, you would have 2 x-intercepts. Okay, it has to be A and it can't be D because A starts with a negative gradient. And we have a negative gradient for x values below this point, right, to the left of that point there. Can't be this because it's got positive x values. So yeah, it has to be A. Hopefully you can see why that's the case. I think it's easy to think in terms of the function than to the derivative rather than looking at this and thinking what's the antiderivative. In my mind, it's too complicated to think in that direction. The answer there is A. Yeah, it's hard. These questions, there's only 4 options in these tests nowadays, so makes it a little bit easier. All right, question 19. Let f of x equal e to the x and g of x equal px. The values of p such there is one solution R. Okay, e to the x is the green line. P of it, px is just a linear line with it goes through the origin, right? So we've got to think to ourselves, where is there one solution? Well, it seems like there's one solution. So let's put it back to 0. It seems like there's one solution anytime it's negative, but not including 0, because when it equals 0, it's an asymptote. Well, it seems like an asymptote to me. Okay, but there's also one solution when it tangents, which is interesting. So if we tangent, you might notice here, when P is around 2.7, it tangents, and then you're going to get 2 solutions past that. So I think the answer here, 2.7, should be jumping out at you as being equal to E. So we said all negative numbers, not including 0, but also E. So I reckon the answer here is D. So yeah, we get D as our answer there. All right, my least favorite question of all. Not my strong suit, but I managed to work out a question. A researcher is studying the average height of adult males in a particular city. After collecting data from an initial sample of 30 men, a 95% confidence interval for the average height is calculated. The researcher then decides to collect a larger sample of 150 men from the same population. What will happen to the width of the 95% confidence interval for the average height as the sample size increases? Assume the mean and standard deviation remain the same. Okay, from the VCAR formula sheet for methods, you'll see this as the approximate confidence interval. If we increase n, let me just show you here. This is our lower bound for our 95% confidence interval. This is our upper bound. So if we change n, whereas we keep everything else the same, so z is fixed for a 95% confidence interval, n is going to get larger. P represents the sample proportion, right? So in any case, if we make n larger all the way up to 150, you'll notice, so it goes from 30 up to 150, the confidence interval gets narrower, right? So the confidence interval decreases. But that should make sense, right? Remember, when you're trying to estimate the population proportion, as your sample size increases, you're more confident that the population proportion sits within your 95% confidence interval. So your 95% confidence interval becomes better in some sense. You're more confident about where, you're more confident that the sample proportion will be somewhere in there. So it sort of gets squished. So you can be more confident if you have a larger sample. So that's the way I think about it anyway. I'm sure there's better ways to sort of explain that, but yeah, the width of the confidence interval will decrease. So yeah, and again, I think hopefully that makes some sort of intuitive sense, but it says here that the standard deviation and mean remain the same. So this p hat's going to stay the same, and that's all these points are. I've literally just graphed those points. I've put coordinates for points that where I can just change n, whereas everything else is fixed. And you notice what happens is the confidence interval gets narrower. So good luck, all you methods people out there. Let me know what you thought of these questions. If you think I got anything wrong, or if you thought it was difficult or easy. You've got, from the time I'm recording this, you've got what, just over 11 days. You got 11 days until your exam. So good luck. I'm rooting for you all. Talk soon.